Hello everyone, this is Matthew Nerdy, and today we're doing May June 2010 paper. So let's get started. So for the first question, it's a bunch of trigonometry formulas, and it says that acute angle x radians is such that tan x is equal to k, where k is a positive constant expressed in terms of k. So part 1 says tan pi minus x. So we know that there's a formula in which tan, if I write pi as 180, it's the same thing. So tan 180 minus x is equal to, the formula is tan x is minus 1. So if tan x is equal to k, so minus tan x is equal to minus k. So for part 2, tan 1 upon 2, or tan 90 minus x. So tan 90 minus x is equal to another formula. It's 1 upon tan x. So k will be 1 upon k. Okay, so for part 3, it says that find out sine x. So we know that tan x is equal to k upon 1, because anything divided by k upon 1 is its own answer. So we can suppose that there's a 1 over here, and we need to find out sine x. So if I draw a triangle, and if this is my angle, we can take this or this, it's your choice. And we put tan, and so what is tan? Tan is still printed black, perpendicular and base. So we know that this is k, this is 1, and for sine we need perpendicular upon hypotenuse. So we need hypotenuse, and we know that the formula for hypotenuse is a squared plus b squared under root. So this is that. So for sine x is equal to perpendicular upon under k squared plus 1. So this will be the answer. Okay. Question 2 says that find the first 3 terms in the expansion of this in descending powers of x. So mostly when it says descending powers of x, it's already like descending. So x power 5, x power 4, power 3, 2, 1, and all that. So you usually don't have to, but sometimes it gives you that you have to do it by your own. But I don't think this question was it by its own. So for part 1, find the first 3 terms. So for first 3 terms, we're just gonna open this hole up till 3. So this is power 5 plus 5c1 times 2x, and 5 minus 1 is 4, and minus 3 upon x power 1 is 1, plus 5c2 is 2x to the power 3, and minus 3 upon x will be the power square. So we know that whenever we square something, the sign changes to positive, and if there's only 1, the sign changes, it does not change. So this will be 2 power 5 is 32. 2 power 5 is 32 x power 5 plus 5c1 is 5. 5 times 2 power 4 is 16, and times minus 3. So the answer is 240. So we put minus 240, and we know that if we multiply it, if we power this, it's gonna be x4, and if we do this by this, it's gonna be x4 upon x1, and 4 minus 1 is equal to 3. So this is gonna be x to the power 3, and plus the third value for 5c2. 5c2 is 10, so 10 times 2 power 3 times minus 3 square, it's gonna be 720. And if you see here, where is it? If you see here, yeah, so if you see here, this will be x power 3, and this will be upon x squared. So 3 minus 2 is equal to 1, so this will be just x. That's part 1. And then part 2 says, oh yeah, we can make this like, we can arrange this minus 240x cubed plus 720x. So we don't have to arrange them because it's already decreasing, the power of 5, then 3, then 1, so it's already decreasing, so we don't need to decrease. We can't decrease this more. Part 2 says, hence find the coefficient of x in the expansion of this and this. Okay, so what does x, the coefficient of x mean? That x is the power 1. So if we need the power of 1, we'll first put 1 plus 2x squared. So we just open this and we'll put this over here, and we've just opened this, right? So we'll put this whole into here, not this over here. So this will be 32x the power 5 minus 240 x the power 3 plus 720 x. That's it. So we need to multiply this by this. So we need to know what do we multiply. If we multiply 5 to the power of 2, it's going to be x is equal to 3, and we do not need x is equal to 3. We need x is equal to 1, x to the power 1, x to the power 1, not x to the power 3. So this and this can match. If we do this, there's x square below, so this is going to be x3 upon x squared, which will make x1. So yeah, this is a valid one, so we'll mark this. And for the last one, 720, if we multiply x to the power of 1, if we multiply this by this, we can get another x value. So if we multiply this by this, 2 times minus 240, yeah, and we'll ignore all the powers of x, because in the end it's gonna become x is equal to power 1, and we just need to find the coefficient of x. We don't need to put x beside this. So this yeah, plus 720 times 1, so minus 240 multiplied by 2 is minus 480. Minus 480 plus 720, and 720 and 720 minus 480 is 240. So our answer will be 240. Okay, so for part 3, it says that the ninth term of the arithmetic progression is 22. So the term of 9 is equals to 22, and the sum of the first 4 terms is 49. So the sum of 4 is equals to 49. So part 1 says find the first term of the progression and the common difference. So we need a and d. So first I'll put this, so first I'll make this formula, and T9 is equals to a plus n minus 1 d, and the term 9 is 22 is equals to, we don't know a, plus we know n is 9 minus 1 is 8, and this becomes our first equation. And I'll just sort it out. A is equals to 22 minus 8d. So for sum is 4, sum 4 is equals to n upon 2, 2a plus n minus 1d, and we know the value of n is 49, and no, we know the sum of 4 is 49, and we know the n is 4, so 4 upon 2 is 2. This is 2a plus, we know the value of this is 3d, and 49 is equals to 4a plus 6d. We know the value of a is this, so we'll plot in a. 49 is equals to 4. We know a is 22 minus 8d plus 6d, and 49 minus 88 is equals to 8 4s are 8 times 4 is 32. So we know 8 times 4 is 32 minus 32d plus 6d. So minus 88 plus 49 is equals to minus 39, and is equals to minus 32 minus 6 is minus 26 d. So we'll put 26 over here. Minus 39 upon minus 26 is equals to d. So the answer for d is minus 39 divided by minus 26, and the answer is 1.5. So we know the value of d is 1.5, and we need the value of a, so we can just plot it in this formula to find the value of a. So a is equals to 22 minus 8, and d is 1.5. So if I plot this in the calculator, 22 minus 8, 1.5, the first value of the value of a is 10. Yeah. So for part 2 it says find an n of, oh wait, so part 2 says find the value of n when the nth term of the progression is 46. So it says that the term n is equal to 46, and we do know the values of a and d, so this will be quite easy. It's like 2 marks. So we know that tn is equal to 46 is equals to a plus n minus 1d. We don't know the value of n, but we know the value of d and a. So 46 equals to 10 plus n minus 1, and d was 1.5. Yeah, so d is 1.5. 46 minus 10 is 36 is equals to 1.5 n minus 1.5. So 36 plus 1.5 is 37.5, and it's equals to 1.5 n, so n is equals to 37.5 divided by 1.5. So divided by 1.5 is 25. So the value of n is 25. So for part question number 4, it says the diagram shows the curve y is this and line is this. Find the area of the shaded region. So we need this area. For this area, we can integrate this curve with the selected points, and we'll get this whole area. And if we minus this whole area by this rectangle, so we can get this answer then. So first we'll intercept the both curves, the both equations. So y is equals to 6x minus x squared, and the other equation is y is equals to 5. So 5 is equals to 6x minus x squared, and if I arrange this properly, x squared is equal to minus 6x plus 5. So we know that 5 times 1 is 5, and x squared is equals to minus 5x plus minus x plus 5 is equals to 0. This is also equals to 0. So we know that x is equals to x minus 5, and minus x is equal, and minus 1 is x minus 5. So we know the first value of x is equals to 1, and the second is x is equals to 5. So this is the point 5, and this is point 1. This is point 1, yeah. So if we integrate this curve, if we integrate the curve with 5 and 1, and we know the equation is 6x minus x squared. So if we integrate it, this is 6x squared upon 2 minus x squared 3 upon 3. So this will give us the integration, and this is 5 and 1. Yeah, so we know the values of 5 and 1. We'll just plot it into the x values. So 6 power actually we can put this 3 and then 5 to square minus 5 cube upon 3. This is my first 5 down, and minus this is 3 squared, and 1 squared is 3 minus 1 upon 3. So this will give us the answer of the whole this area, and we'll subtract it from this rectangle. Just solve this. So in the calculator, 5 squared minus 5 minus 5 cube upon 3. So this will give us a repeating decimal, so I'll just put it in the fraction. 100 upon 3 minus 3 minus 1 upon 3. It's 8 upon 3. So 100 upon 3 100 upon 3 minus 8 upon 3, it will give us 30.67. So this is the area of the whole this, and if we need to know the rectangle, we know that this is the point, this point is this one. So we know that this point is 1, 5, and we know that this point is 5, 5. So that means that the height of this rectangle is 5, and the length of this rectangle is 1 till 5. So this is 5 and this is 4. So 30 minus 67 multiplied by 5, no, minus 5 times 4. So 30.67 minus 20 is 10.67. So that's the area. So question 5 says that the function f is such that this is this and this is that, expressed in the form of a plus b cos square x, stating the values of a and b. So let's just plot this first. 2 sine square x minus 3 cos square x. So we need in this form, so we know that 1 minus cos square x is equals to sine square x. So we can plot this into this, and we also now know that 1 minus sine square x is equals to cos square x. Now why can we put this equation over here is due to that we don't need it we need the answer in cos square x. We don't need the answer in sine square x. So that's the whole reason. So this will be 1 minus cos square x minus 3 cos square x. So this is 2 minus 2 cos square x minus 3 cos square x. So this is minus 5 cos square x, and that's the answer. So A is 2 and B is minus 5. So for part 2 it says that, I'm just making space. So for part 2 it says state the greatest and least values of fx. So okay, this is easy. So for part 2 we know that anything cos x, so we know that the range of cos x is 1, minus 1 and 1. So if cos square x was implemented, we know that anything square is this will be just 1, and this will also be 1, but we know that anything square is positive, so the least can be 0, and we'll just plot these two values into the equation. Okay, so we'll put 0 and 1 into the equation. So first let's put 0. So 2 minus 5, 0 is 2, and 2 minus 5 to the power 1 is minus 3. So we know that the largest value is 2 and the smallest value is minus 3. We just type it. The largest is 2 and smallest is minus 3. Solve the equation fx plus 1 is equals to 0. So we know the equation that the equation of fx plus 1, we know the equation of fx. We'll just plot this in here. So 2 minus 5 cos square x plus 1 is equals to 0. So this is 3 minus 5 cos square x is equals to 0. 3 goes over there, this, and then minus 5 cos square x is equals to, so this becomes cos square x is equals to 3 upon 5. So we can take the square from cos square x and we can put it into the 3 upon 5. I don't have space, so I'm writing over here. I'm gonna make a lot of lines. So cos x is equals to under root plus minus 3 upon 5. We know that that this is in radians, so we'll put our calculator in radians. And so first we need to find the alpha. So alpha is equals to plus or minus, plus minus, cos minus 1 is plus or minus under root 3 upon 5. So the alpha for solving alpha, we need cos inverse under root 3 upon 5, and we need this in radians. So my value comes 0.6847 plus or minus 0.6847. So we'll ditch the minus because we know that this value is only from 0 to 180 and we can go negative, so we can go 0 to minus 180. So we'll ditch the negative and this will be 0.6847, and we know that the cos is positive, so we'll make a graph, a trigonometric graph. Add sugar to coffee, and we need the sign positive, so cos positive, so cos is positive in the first quadrant. Add sugar to coffee, and the fourth quadrant, this and this. So this is 0.685. Let's round it off. This is 0.685. So for the first value of x, is it x? Yeah, it's x. For the first value of x, we know that we don't need to do anything for this because it's already in the first quadrant. So 0.685, and for the last quadrant we always minus it by 360. So this whole is this whole is 360, and this is the area that is covering the 360, so we minus this from 360 and we get the answer. And 360 is 360 minus 2 pi minus 0.685, and that is 5.598. So we now need to look at the range and does the domain allow it. So unfortunately the domain does not allow 5.598 because the value of pi is 3.14, and this value should be under that, not above it. So this value is cancellable. 0.685 is the answer. Alright, so this was part 3. So question 6 says that a curve is such that the gradient is this and the points lies on the curve is this. Find the equation of the curve. So we know that if we integrate this whole equation, we get the equation of the curve plus c. We get plus c2, and by putting the x and y's we can figure out the value of c. So let's integrate part 1. dy upon dx integration is equals to 3x 1 upon 2 minus 6 times dx. So we know that if we integrate the power, it gets a plus, so 3x, and 1 upon 2 plus 1 is 3 upon 2, and divide by 3 upon 2, and I'll just write it as 2 upon 3. This goes here, this goes here, because it gets reciprocal. So minus 6x plus c. So let me just arrange this. This is 2x to the power of 3 upon 2 minus 6x plus c, and this is all equals to y. So now if we put our value of this, we can find the answer of c. So y is 2 and x is 9. 2 power 9, 3 upon 2 minus 6, 9 plus c. So 2 minus anything that goes here, 2 to the power 9, 3 upon where's upon 3 upon 2, and minus 6 power 9. Alright, so so this whole is 0. So this will be c is equals to 2. So our equation is y is equals to 2x to the power of 3 upon 2 minus 6x plus 2. So it says find the x coordinate of the stationary point on the curve and determine the nature of this. Okay, so we know that the stationary point, so what the stationary point means, that the gradient is 0. So if we do dy upon dx is equals to 0, and we put 0 is equals to 3x to the power 1 upon 2 minus 6, and we put 6 upon 3, and this is under root, so this will get squared, is equals to x. So 6 upon 3 is 2 to the power of 2 is 4. So the value of x is 4, and we need to determine the nature of the stationary point. So we'll differentiate the gradient or this equation. We'll differentiate it again. So d square y upon dx square is equals to so we know that 3x and 1 upon 2 minus 1 is minus 1 upon 2 divided by 2 minus 6 is just gonna get cancelled. So we know that the value of x is this, so d square y upon dx square is equals to 3 and 4 power minus 1 upon 2 upon 2. So 3 upon 2 and x is 4 minus 1 upon 2. So our answer is 0.75, which tells us that this is a minimum curve. So question 7 says that the diagram shows part of the curve this and crosses the x-axis and y-axis at this. Show that the equation of the line AC, where it's AC, this is AC, so the line AC is this equation. Alright, so we know that this is a curve and the gradient of the curve is we know that this is a curve and this is the tangent, and we know that tangents are perpendicular to normals, so we know that whatever the gradient is, it's gonna get minus 1 upon m. So first we'll get the point of this. This is 0. This is x something 0. So if we put y is equals to 2 minus 18 and 2x plus 3, and yeah, so y is equals to 0, so 0 is equals to 2 minus 18 2x plus 3, and 2 is equals to 18 2x plus 3, and 2 times 4x plus 6 is equals to 18, x is equals to, so 18 minus 6 is 12, divided by 4 is 3, so x is equals to 3. So this value is 3, 0. So now we know the value of this is 3, 0, and this is 0, y. So if we need to know the points of this side, we need to know this gradient. And if we know that this is a curve and we differentiate the curve, we get a tangent. So the tangent will have a gradient. This will tell us the gradient, and if we reciprocal this gradient and multiply by 1 minus 1, we'll get this gradient. So then we'll get the equation. So first we need to differentiate the equation. Y is equals to 2 minus 18 2x plus 3 to the power of minus 1. So first we need to differentiate it. So anything dy upon dx is equals to 2 will get disappeared. Minus 18 is a constant, this will stay. 2x plus 3 will also stay. Minus 1 is minus 2. This will have the differentiation of this. This will get 2, and the differentiate of the power. This is minus 1. So dy upon dx, 18 upon, wait, wait. We can just do this. So this gets cancelled. This gets 18 2s are 16. 18 times 2 is 36. So this is the answer, 36 upon 2x plus 3 to the power square. So we know one value of x, that is 3. So if you put 36 upon 2 to the power of 3 plus 3 square, we'll get the gradient. So 36 divided by 2 multiplied by 3 plus 3 and square. So this becomes 4 upon 9. So our gradient is 4 upon 9, and we know that the gradient is this gradient. So we need to reciprocal and multiply by minus 1 to get the gradient of the normal. So this becomes 9 upon 4 minus, this is a gradient. So we know that the equation y minus 0 is equals to x minus 3 minus 9 upon 4. So I'll just cross multiply this. 4y is equals to minus 9x plus 27, and that's the equation. So part 2 says that find the length of BC. So for BC we know the equation of the curve, and for equation of the curve we'll just put x is equals to 0, and we'll get this point, and we can just plot this. And yeah, we can find the value of y actually. Alright, yeah, so finding the plot of y, you just put this in the equation. So let's find y first. So if for point C, we know that the point C is 0 comma y. So if you put the equation for y is equals to minus 9x plus 27, yeah, plus 27. So 4y is equals to minus 9 multiplied by 0 0, 27. So y is equals to 27 divided by 4. Y is equals to 6.75. So that's the point of C, and now we need the point of B. So for point B, we know that the value is 0, and we don't know the value of y. So we can just plot in the equation. Y is equals to 2 minus 18. So 2 times 0 is 0, so this is 3. Y is equals to 6 minus 2 is minus 4. So y is equals to minus 4. So we know that the equation of these both are there, and we can just put the equation of the length. So y1 minus y2 plus that square, and x1 minus x2 square. Actually this is 2 minus 1, and yeah, I put it opposite. So 2 1 2 1. So what do we know that minus 4 minus 6.75 square plus 0 plus 0 square. Yep, under root that. So this will give us B and C, B and C, B and C. Let's plot that in the calculator. Minus 4 minus 6.75, the power square, 10.75 is the answer. Alright, so question 8 says that the diagram shows a triangle ABC in which A is 3 comma minus 2B is this. The gradients of AB and AC and blah 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 are this. Wait, let me just type it. So AB is 2m. Wait, I'll type this. 2m, and AC is minus 2m, and the last one is just m. M is a positive constant. Find the find the gradient of A and B and reduce the value of A and M. So we know that the gradient of A and B. So part 1 is simple: y2 minus y1, y2 minus y1 upon x2 minus x1 is equal to the gradient. So y2 is 22 minus plus 2 upon x1 is 15 minus 3 is equals to gradient. So the gradient is equals to 22, 15 minus 3, 22 plus 2. So the answer is gradient is 2. So for part 2 it says that find the coordinates of C. So we know that the gradient of AC is equals to 2 minus 2 and gradient of BC is equals to 1. So we can figure out this. Let's figure out the point of C. So y2 minus y1 upon x2 upon minus x1 is equals to the gradient of minus 2. So if we know that the gradient is minus 2 of what? AC, yeah. So A and C, we know that this is 3 minus y upon so y2 is minus 2 minus y upon 3 plus 3 minus x is equals to minus 2. So I'll just cross multiply. Minus 2 minus y is equals to minus 6, and this will be positive 2x. So minus y is equals to minus 4 plus 2x. This is one equation, and comma. Let's just do this. y2 minus y1 upon x2 minus x1 is equals to 1. So what's the value of b? B is 15 and 22. So 22 minus y upon 15 minus x is equals to 1. Cross multiply this. 22 minus y is equals to 15 minus x. So let me just put minus y is equals to minus y is equals to 22 minus 15 is 7. So minus 7 minus x, yeah. So let's put both equations together. Minus 7 minus x is equals to minus 4 plus 2x. So minus 7 plus 4 is minus 3, and 2x is just 3. So x is equal to minus 1, and it should be minus 1 because looking at the graph, yeah. And the value of y can be simply put in. Minus y is equals to minus 4 plus 2 minus 1. Minus y is equals to minus 4 minus 2. So y is equal to 6. This is 1 comma 6. So question 9 says that the function f is defined by f is this expressed in the form of this. So for part 1 we know that 2x squared minus 12x plus 7. So we need to make it in the form of completing square form or whatever it's called. So first I'll take the common of 2. X squared minus 6x, and I'll leave 7 outside. So why I leave 7 outside is if I divide it by 2 it's gonna become a fraction, and in the end it will give a answer of whole number, but I don't want to work in fractions, so I can just do this. So now I can so now I can do x squared. So now I can do x squared minus 6x. What 6x? 6x. And now I can put 3 squared minus 3 squared. So I'll divide this by 2 and put squares on both sides, and I'll make one positive and one negative. So even if we do this, even if we add or subtract these both, it's gonna give us 0. So and this will be closed plus 7. So now I'll just take the common of these 3 and make this into x minus 3 whole square, and in the same line I want to make this outside of the brackets. So if I need to take this outside of the brackets with the plus, like minus 3 or whatever, like minus 3 square, so I need to multiply it by 2 because this whole is multiplying by 2, and if I need to make this whole brackets open, so I'll just multiply this by 2 and the bracket will open. Not the whole bracket, but I can just take out this value. So this will be minus 2 and then 3 square plus 7. So this will be 2x minus 3 whole square minus minus 2 3 square is minus 18 plus 7, and this will be 2x minus 3 to the whole square minus 11. So part 2 says find the set of the values for x for which fx is lesser than 21. No, actually part 2 says state the range of f. So if we draw out the diagram, if we need to plot the graph, we can look at this and we can from this we can make a graph. So we first need to know that will the graph be a happy face or a sad face. So this is a positive graph and this is a negative graph. So we look for positive negative over here. If 2 has a positive sign, so it will be minimum curve, and if 2 has a negative sign, it's gonna be a maximum curve. So over here it's gonna be a minimum curve, and after that we need to know the turning point. So the turning point we can know by these two values. So this is the x value, this is the minus x value, and this is the positive y value. So if we do x is equals to 3 and y is equals to 11, whatever the sign inside this, it will get removed. So if it's minus, it gets plus, and if it's plus, it gets minus. So now let's make the graph. So turning point is equals to 3 comma minus 11, and it's a minimum curve. So let's make the curve now. 3 will be somewhere over here. Minus 11, we can just make minus 11 over here. So this will how my graph will look like. It says state the range of f. So for the range of f, we know that we can't go below the lines, and the only place left if we can go below is above. So this hole is the area. This hole is the range in which all the values can proceed in. So what's the minimum point at which this hole is here? So the minimum is this point, and this is minus 11, and we need the range of this. So this is the range. Y is always the range. So for part 2, our range is y is greater than minus 11. And why we're not putting an equal to sign is because we're looking at so this is the answer of y is equal to is greater than 11. So for part 3, it says that the function find the set of values of x for which fx is lesser than 21. So we know that fx is equals to 2x squared minus 12x plus 7 is lesser than 21. So if we put 21 over here, if we take 21 over here, it's going to be 2x squared minus 12x minus 14, because minus 21 plus 7 is 14. And this will be lesser than 0. So we can just divide this whole by 2. This will be x squared minus 6x minus 7. And the factors for making this a whole number, so the factors, we know that it can be 7 and 1 to make 6. So x squared minus 7x plus x minus 7 is lesser than 0. Actually, I'll put this is equal to 0. So x is x minus 7, and plus 1 is x minus 7. So we know that the values are x is minus 1 and x is equals to 7. So if we make our graph, actually I'm going to copy the graph. So if I copy this graph, so if I copy this graph, I know that this is equals to minus 1. This will go here, but I've just made it already. And this is 7. So it says that the values are lesser than 0. So this will come beneath 7, beneath the value of 0. And so we can just make this into a domain. So minus 1 is lesser than x, and this is lesser than 7. So x is greater than minus 7, and x lies between 7 and minus 1. So this is part 3 done. Part 4 says the function is g is defined by this, and we have to put gaf is equal to 0. So for gf, we'll put this whole value into the value of x. So part 4, g is 2x is the function f, 2x squared minus 12x plus 7 plus k, and is equal to 0. So let me just open this up. 4x squared minus 24x and plus 14 plus k is equal to 0. So the question says that this whole equation has two equal roots, and how do we find roots? We can find roots by putting b squared minus 4ac, and we know that it's two equal roots. So what does two equal mean? That it's just the one value, which it's a one, it has one value, but it's equal to each other. Like it had. So what does two equal roots mean? It means that there's two values and they're both equal to each other. So we'll put b squared minus 4ac is equals to 0, and we can say that b squared is this, and no, we can say that a is this, b is this, and c is this whole. So b squared is minus 24 square minus 4a is 4, and c is 14 plus k, and this whole is equals to 0. So 24 square, so 24 square is 576 minus 576, and minus 4 times 4 is 16, minus 16, 14 plus k. So 16 times 14 is 224, and minus 224 minus 16k is equal to minus 576. So I'll just do this all in my head, so like in the calculator. So minus 576 plus 224 is minus 352, and minus 352 divided by 16 minus 16 is 22. So the value of k is equals to 22, and that's part 4 done. So question 10 says that the diagram shows the parallelogram OABC and then again O. Given that OA is this, OA is equals to this, OC this is equals to this. Find the unit vector in the direction of OB. So OB is this. So if we need to find OB, we can say that OA plus AB is equals to OB. So we know that this is a parallelogram, and in parallelogram the opposite sides are always equal. So OC is equal to OAB. So I'll just put part 1, OP is equals to OA plus AB. So I'll make this into the vector form. OA is 1, 3, and then 3 plus AB. What is A? AB is OC, so I'll just put 3 minus 1 and then 1 is equals to OB, and this will be 4, this will be 2, and this will be 4 again. So this, we have found the vector of OB, and now we need the unit vector. So I'll just divide this whole by these three values, and this is 4 squared plus 2 squared plus 4 squared is equals to, and this becomes 6. So 4 to 4 divided by 6. So let's just divide this whole 3. This is 2, this is 1, this is 2, 2. So 2, 1, and then 2 divided by 3. So I'll write the answer in this form that's given in the question. I'll type it over here. So 1 upon 3 multiplied by 2 plus 1 upon 3 multiplied by 1 is 1 plus 1 upon 3 multiplied by 2 is equals to OB, and OB is equals to 2 upon 3 plus 1 upon 3 plus 2 upon 3, and this will be I, so this will be J, and this will be K. So this is the answer of part 1, and that's it for this video. So that's it for this video. If you want to know some other past papers, if you want me to crack them, I can do those too, and I'll meet you in the next video.